moving forward with the next, we have here the next part is about urban biocycles, waste and water. We will have two guests, Coos Wessels from CirTec, and then later on Marco Bersani from Circular Materials. So I invite Coos Wessels, please. The title of your speech is From Toilet Paper to Value Paper. Really interesting.
Yes, thank you for the invite. I tried to highlight a little bit about what is our business, upgrading toilet paper to value paper. First, a short introduction on CirTec. CirTec is an acronym for circular technology, meaning that we focus on recovery of valuables from sewage and wastewater streams, and we use low-value residual energy for treating concentrated waste streams. This presentation is about the recovery of cellulose from sewage. I try to avoid the word wastewater, because I think that sewage is a valuable source of a lot of materials, and that's what this is all about. First, I heard this morning already a lot of nice examples on how you can reuse materials again, and we're looking at circular targets in 2050 as if it's far away, but it is in less than 30 years. So we're talking about it already quite a long time. And if you look where we are right now, yeah, then you see that we are on our way to consume about 3 times what the Earth provides us at that time. So if you look at a graph that was in the newspapers about a little bit over a year ago, you see that the consumption of all natural resources is still increasing worldwide. So if you look at here at this graph that was published about a year ago, on minerals, on biomass, on fossil fuels, and on metals, on all fields, we are increasing our consumption. That's worldwide. But if you look at the European countries, it's about the same. So we are increasing our consumption. And from that perspective, we look at recovery of valuable materials from different sources, and sewage is one of them. And I think that sewage can really make an impact on this. From a project that we are involved in, we looked at different resources, and on this sheet there are 3 examples. Cellulose is one of them, because this is our business, but there are others. And if you look at cellulose, we could recover in Western Europe only about 4 million tons of cellulose, the base material from toilet paper, and give it a new destination, reuse it. If you look from bioplastics, sewage has the potential of having 1.03 million tons of bioplastic in it. And if you look for phosphates, this was already published about 2 years ago. In the Western European countries, we can take about 26% of the need of phosphate back from sewage. So it can have really an incredible impact. But yet, up till now, knowing that, we only use about 1% of what is in our sewage water. So there is a long way to go before 2030 and 2050, I would say. To put it in numbers, I don't want to bother you with all the numbers in this sheet, but here you can see that Italy is, in Southern Europe, the largest consumer of tissue paper. And some numbers in it, if you look at the tissue consumption in Europe, it's about 9.6 million tons of tissue that is consumed. It not all ends up in sewage, of course, because we use it for all kinds of other things. But about 6.5 million tons ends up in our sewage system and comes up at the sewage treatment plant. From that, we can recover approximately 4.5 million tons of material. tons of material. It doesn't say too much to a lot of people. So if you would make a kind of calculation, we're talking about something like 4.9 million trees a year that we could save. And if you compare that again, it would compare with a forest of 29,700 hectares. So a lot of forest. Then we didn't come up with the idea in the morning of, okay, we're going to harvest toilet paper from sewage. Basically, the idea came from a contest from the Dutch water authorities, where one of the water authorities came up with the idea that sewage contains more energy than it will take to purify it. So theoretically, you can can produce energy while treating your sewage. And from this idea, we started to sieve material from sewage. And in the first stage, look at making biogas out of it as a first step to produce energy. The first customer of us put this material that we sieved under a microscope, and it proved to be a majority of toilet paper that we sieved out. And as a kind of a commercial thing, he printed paper from it, and that started the idea of recycling toilet paper from sewage. So we started to harvest material by sieving influent from a sewage treatment plant, and we built a couple of large-scale plants in this as well, because the first material, it had about 60% of cellulose in it, and we thought, okay, this is a marketable product. With implementing new technology at the treatment plant, if you do something new, you answer one question and you get about a dozen of new ones. So we had to do a lot of research at all kinds of scales to see what the impact would be downscale on treatment plant. Well, if you look at what the impact would be by sieving your sewage, you will find that you consume your energy. You take out carbon, so the energy consumption for aeration, but also due to less sludge production, will be reduced with approximately 20%, 15 to 20% of energy reduction. As I mentioned, you produce less sludge, so you have less waste, and with the less sludge, you consume less polymers. A nice side effect is that we take out all fibers, but we also take out a lot of hair. So it's reducing your maintenance cost. And next to that is you have the opportunity to harvest a marketable material. If you look at the average, what we see in the Netherlands on characteristics of composition of the material that we harvest, you can see that it is 65 to 75% cellulose. You see fats, sand, proteins, and all kinds of things in it. And I added some pictures of a biology where you see that you have less fibers in the biomass present. So the activity of biomass increases, and you see some pictures of filtrate. So what do? We inline now separate a residual stream, and in the second stage, we take out the cellulose. So what you do without additional pumping, behind core screening, we install a two-stage filter system, taking out these materials where the residuals, as we call them, it still has quite an organic content, so you can make biogas out of that. But the cellulose, and for those present, I have some example here. This is Italian cellulose harvested here from this area. You can give that a second life. So if you look at it from a perspective, yeah, we compare sometimes cellulose harvesting with sieving influent, but it's not the same. So we really take out in two stages, first residuals, then cellulose, the marketable product. And again, the effect on what it does, it lowers the load on a treatment plant, it saves energy, or it reduces the energy consumption. And again, you have a marketable product. And we developed some markets for that product. So we actually, all the cellulose that we take out of sewage treatment plant ends up in a high-end product. Examples are we sell it to the asphalt industry, we use it for bio-based chemicals, we apply it in biocomposites, bioplastics, and we have a certified product as insulation. Again, we have here some examples for those here on biocomposites if you want to see it, but there's really a market for it. So the demand for our cellulose is much higher than what we can produce nowadays. You have, just to give you an impression on where we started, as mentioned, we started by sieving material, but then taking out different components, it took us a long way because synthetic fibers, they are about the same shape as cellulose fibers. Hairs, they are smaller than cellulose fibers, but first you have to get them out. So we went through a long route. Sorry. We started in the laboratory, taking all kinds of tests, manual sieving. We built all kinds of setups to go through a research program, built first some larger scales, did tests with that, built more large scales, and nowadays we have it up and running, proven technology at full scale. So harvesting cellulose each day, operating machines, and selling it to the market. Then again, if you do something new, you get a lot of questions. And from this perspective, we also looked at the life cycle analysis, or we had looked at it. German consultancy company, Kompetenzwasser Berlin, looked at the life cycle analysis of our technology. And at first, you have to take the base of what is the life cycle analysis. So we took the treatment plant where we have installed our technique. It's a 300,000 people equivalent system where they have grit removal, core screening, then a biology. Sludge is dewatered with a centrifuge, then transported to a dryer, and past that it's co-incinerated. In the next stage, we put in our technology in it, and we looked at the different steps in the process. So at the treatment plant, you have some savings. It is here, I think, about 0.7 kilograms per ton of material of CO2 that we reduce. Of course, you bring in material and you have some additional energy consumption, but also in the value chain, we reduce the CO2 emission. And if you would take it as an average, each ton of resell, what is the name of our product, saves you approximately 2.5 tons of CO2. Then some examples of products that we make. As mentioned, we sell it to the asphalt industry. What is nowadays the biggest market. We sell it as a stabilizer for that. 2 reasons to go to that market. It's a little bit further away from human use, directly close to us. But besides that, we also developed together with producers products like biocomposites, biochemicals. As mentioned, we have a certified material for insulation, and we really sell it. Then some other topics, because doing this, I would say that as an entrepreneur, you should be a little bit crazy to go into these kinds of developments. One of the issues is, I would say, the legal aspects around reusing material coming from sewage. In the basis, if you extract the material coming from a waste source, the material that you harvest is a waste. And we deal with it that way. And we deal with it differently in different countries, in different regions. So as one of the previous speakers said, value chains don't end by the border. This is something that is really important. Theoretically, we have to go every country for every final product, again, through an end of waste status. And the procedures are not the same. So you have to find out the wheel again and again and again and again. To give you an idea, in the Netherlands, it took us about 4 years to come to a level where somebody said, well, this file is quite complete. So we did not get a decision on it, but the file was complete. And we're already up and going for that for about 6 or 7 years. Something strange here happens also, that if we would get it in the Netherlands, yeah, then we have a product. I can transport it over here to Italy. I can sell it to you all. But making the same product in Italy have to go through the same process. So besides technological developments, we really have to make some steps here. Another issue is that within our world of water and wastewater, we think that we harvest material from a fecal contaminated source. So a lot of us have the idea of who wants to buy this material from us. We had the University of Groningen, the Faculty of Social Sciences had a look at it. And it seems that the market is really open for our products. We are the problem ourselves, I would say. So we think that nobody wants to buy it. And because of that, there's also a lot of entrepreneurs who are looking for reused materials. They are also reluctant to use it. So we have to overcome our own thoughts in that respect ourselves. And as last, when you develop as a technology company something new, you can do it, build it once, twice, maybe 3 times, but then you end up in tender procedures. There's nothing wrong with tender procedures, but we try to compare new technologies, new developed technology with existing things, and we try to put a value on it. And this is always a difficulty where you end up, because people don't know really the differences, but they try to make a comparison in it, and it's really a difficulty. So don't misunderstand me, it's not a complaint, but I think that as technology companies and those who are involved in, I would say, procedural kind of things and the legal status of things, we have to cooperate in this to understand it good in the correct way and to make the right decisions on it, because one of the previous speakers also said, getting into circularity is something that we all have to achieve. It's not a problem of them or those or us, it's our problem, and we really have to make some steps into this. So this is, in short, what I would like to talk to you. If you have any questions, I'm here, and I'm here with our Italian partner, that is Giotto Water. So feel free to ask to any questions. So thank you for your attention.
Thank you, Mr. Wessels. I think what you showed us today was really the essence of the circular economy. So you basically take an output, a waste that nobody wants, and you transform it into an input, a marketable product. So I really hope that consumer mindset changes as soon as possible and gives you some heads up in the development of your project. So thank you.